This is 点许 NetID JXQ9011, and my project is about video captions. And I'll first go through what my project is, why I'm doing this, and how I'll be doing it. My project is actually inspired by this real-life problem I have with YouTube videos. There are a lot of product review videos, and they're really helpful, and I watch them a lot. But this video, for example, it's about 5 best-selling products. And what if I'm only interested in one of them, and I wish that I could see only that clip and not the entire video? There's a lot of elements to a YouTube video. There's a video, of course, and there are frame-by-frame images, and there's the audio, and one more thing is that there's the subtitle. And the subtitles will be what I will be working with in this project. Because I could not find any existing dataset that will fit this problem, so I have to come up with a dataset on my own. And instead of product review videos, I found that there are ads videos, and they're better than product review videos because they're smaller. It will take me less time to label them. And another good thing is that a lot of times the title of these commercials are actually the name of the product. I found this amazing API and its relating codes, so I can download a bunch of subtitles at one time. A quick look of what my raw data looks like. There's the timestamp and there's also the actual subtitles. And for obvious reasons, I'll first discard the timestamps and work only on the actual subtitles. Because this is an NLP problem, so the first step is to pre-process the input and the output. This is a very essential and important step. And procedures include removing the punctuations and regularize all the letters, make them to lowercase, and remove the stop words, and tokenize them, and basically breaking them down into one word after another and after another. And also I did some lemmatization, which is a quick demo will be replacing allergies to allergy because they're actually the same word. And the last step is to duplication to remove all the repeated words. After pre-processing, we can move on to word vectorization, in which it is basically an implementation of the bag of words. I will establish a vector whose dimension equals to the number of the total amount of words appears in my dataset, and I will count every word by its appearance for every sample, and basically this establishes the input. And the same thing is done to the output, except that everything is labeled 0 except for the ones make up the actual name of the product. And after that, we can actually move on to the learning process. And the first method that I tried out is what we've been doing throughout this course, which is gradient descent. And I also used fully normalized gradient descent after some little experiments. And I also introduced the F1 scoring to see how well it actually did. So on a toy dataset which contains 2 samples, I think it did well. So this is a learning curve, and here's the test result. The first product is Wash Wizard, and it outputs Wash Wizard, and the other one is EECS, and it did well. Here's the actual timestamps, which I was mentioning what I wanted to achieve. And I move on to a slightly larger dataset, which contains around 50 samples, and well, it did not score very well. And the precision is good, which tells that all the words it outputs are basically within the name of the products. However, the recall rate is very low, which means that, for example, the product name is EECS, it may be only finding Zippy to be a part of the name and miss the sac part. And it happens to a lot of samples. It struck me later that I can actually use the same method on lyrics and songs and use the name of the songs as the label. And I tried it on a dataset, and I think it did slightly better than the ads. And I think it's because how the data are organized. Maybe the lyrics are more obvious to see or something like that. What the gradient descent method failed to provide is to make connection between different words. And I think it's an important part because words obviously mean different things when they're put together with different words. So I thought that maybe I can try out LSTM. So I found this LSTM model on the GitHub website, and I made some slight twist to it. And on a single set sample, this one's EECS, for example, after a little time of training, it does output the exact tag, which is the EECS. But the problem is that I don't think I have a good enough understanding on the LSTM system. And this is only the training. I do not know how to put it to test yet, and I do not know how to generalize it to a greater set of examples. So in conclusion, I came up with a method that will capture the keywords, the most important words, maybe the title, and generally speaking, the words of the most concern from a piece of content. And if it's a subtitle, I can output its timestamp, so you can navigate through your videos better. And I tried out gradient descent and LSTM. The gradient descent method, I think it works quite okay for more simple and shorter samples. But because this is not a very complex, and somehow this method is quite straightforward and it's not that complex, so I cannot see it work better or work decent on larger and more complex contents. LSTM method I think has great potential, but I just don't understand the system and the mechanism that well yet. So I will be trying out that in the future.